Hello there, my name is Tanmoy and I'll be one of the TAs for CS3510 this fall. I hope to be making videos to help with our flipped classroom style mode of instruction. While Jake's videos will be teaching you the actual content of the course, mine will be going over a few examples and hopefully giving you an intuition for each type of problem that you would come across in this course. Today we'll be going over the major concept covered in the first week of the course and also showing you a good way of working through your homework assignment. Now, as the name of the class suggests, we will be analyzing algorithms in this class. And one major component of our analysis is going to be the running time complexity. After watching the lecture video for big O notation, you should have a decent idea of what it majorly involves. But just to recap, it is a method to provide bounds to functions, often functions describing the runtime or space complexity. This class only deals with the runtime complexities, and the three major notations are big O, big omega, and big theta. You can think of them as being the worst case, best case, and average case running times. To start, let's look at a few of these sample problems. Here you have to indicate whether a function f is equal to big O, big omega, or big theta of g. There are many ways of going about getting a feel for the answers, but the way I recommend is simplification followed by comparison. You can think of it as whether f is greater than equal to, less than equal to, or equal to g after simplification. For the first question, we can say that after the constants are dropped, they are both in the order of n, and hence you could think of them as being equal to each other for the bounds, and therefore f is big theta of g. Similarly, for the second problem, we should recall that runtimes are bounded by the more expensive or dominant term, and since n is going to be larger than log n, we look at asymptotic bounds. They are going to be both of the order of n again, and therefore f is big theta of g, since they can be thought of as being equal to each other for the bounds. And now for the third problem, we are comparing a factorial with an exponential function. We should recall that factorials actually grow faster than exponentials. Hence, f is big omega of g, since f can be thought of as greater than equal to g for the runtime. Now for the fourth one, we need to use some log arithmetic. After dropping the constant 10 from f, it is of the order of n. And as for g, log of n squared can be reduced to 2 log n, and when that constant 2 is dropped, it is also of the order of log n. And hence, f is big theta of g, since they are both equal to each other for the bounds. And here for the last problem, we are comparing two functions with the same base but different powers. And since we know that 2 over 3 is greater than 1 over 2, we know that f is going to grow slower than g. So f is less than equal to g for the bounds, and hence f is big O of g. When it comes to actually working on your homework assignments, I would highly recommend using a website called Overleaf and writing out your solutions in LaTeX so that they're formatted correctly. We would be providing out LaTeX templates for your assignments throughout the semester, and it can be as easy as writing down your solutions in the prescribed format and then downloading a PDF of it to be submitted to Gradescope. And that should cover the basics of what we will be facing in the first week of the course. If you have any questions at all about any of the concepts taught, feel free to reach out to us on Teams or post your questions on Piazza. We will get to them as soon as possible. We wish you the best for this upcoming fall and look forward to working with you all.